Hello students, welcome to this session on sensors. In this session, we will first understand what are sensors, what are the elements involved in sensing process. We will also understand the desired features of sensors, what are the different ways of classifying sensors, and at the end of this video session, you will be able to justify what are the parameters for selection of a sensor for a certain application. So let us first look at what are sensors. We have used sensors in our day-to-day life. For example, the thermometer is a sensor which is used for sensing body temperature. Whereas we might have used sometimes a microphone which is used in a public address system to convert sound energy into electrical form. So both these are sensors. So what are sensors? Sensors are those devices which can be used to measure or detect a vast variety of physical phenomena. They can also be used to detect certain chemical phenomena. They can be used to measure biological quantities like proteins, bacteria, chemicals, gases, to measure light intensity, to detect motion, to measure what is the position of an object, to convert the sound energy into some other form. So these are all different physical phenomena which a sensor can capture, can measure, or can detect. And these sensor measurements are then converted by a transducer into a signal that represents the quantity of our interest, and then this signal is presented to the external world. So the sensing process involves three basic elements. The physical quantities which are to be measured or captured or detected, like proteins, bacteria, sound, which can be measured, motion can be detected, chemical gases can be detected. So all these physical quantities can be sensed, and their measurement is passed to an intermediate element, which is the transduction element, which converts this measurement into an appropriate output signal. The output signal typically is in the electrical form or in the optical form, and then these signals can be processed further. So three basic elements in the sensing process. So sensor is a device which detects a physical change in one form of energy and converts typically into electrical or optical form. Whereas transducer is a device which converts a signal in one form of energy to another form. A transducer may not be capable of detecting a change in the physical quantity, but it is certainly capable of converting one form of energy into another form. An electrical transducer, in a way, is a sensor which detects the physical or the mechanical change, and then it also transforms this particular change into a suitable electrical voltage or current, which is proportional to the quantity which is being measured. So there are certain desired features of electrical transducers. The first amongst them is the linearity. The linearity is a relation between the physical parameter which is being measured and the resulting electrical output signal. And if this relationship is linear, then it is a preferred transducer. So if Y in this particular graph represents the output signal that is in the electrical form, and X is the physical parameter which is to be measured, then if this relation has to be a linear, then it must be of the form y is equal to mx plus c, where m is the slope of the line and c is the intercept. In this first graph, we have shown that this slope is a negative slope, whereas in the second, we have shown a line with a positive slope. So in both these plots, the relation of the output and the input is a linear. In order to distinguish linear and nonlinear relationships, we'll just see two quick examples. Here y is 10 plus 5x squared. So y is related to x as a square in a squared relationship. Y is related to x squared. So this is no more a line, but it is a curvature, hence a nonlinear function. Similar way, here it is a relation of temperature versus time. And this relation in blue curve is also not a line, but it is a curvature. Hence, it is a nonlinear function. We desire that a transducer has a linear response, linear relation between output and the input. The second most important feature is the sensitivity, which is defined as the electrical output per unit change in the input physical parameter. So if there is a unit change in the input parameter, how much does the output change? So greater the output change, the better is the sensitivity. Hence, high sensitivity is generally desirable for a transducer. For example, if we have a displacement sensor and then the displacement changes by around 1 millimeter and it generates an output voltage change of 200 millivolts, then the sensitivity of this particular sensor is 200 millivolts per mm. So if a sensor has a linear relationship between the input and the output, then the sensitivity is a constant, because if it is y is equal to mx plus c, then dy by dx is m, that is the slope which is constant. However, if it is not a linear relationship, then the sensitivity changes with the input. We have shown here a graph which contains 3 lines. The bottom line is having the least slope, therefore it indicates low sensitivity. The center one is with medium slope, hence it indicates medium sensitivity. Whereas this particular line, which has the highest slope, is high sensitivity line. So higher the sensitivity, greater is the change in the output for a small change in the input parameter. However, higher the sensitivity, narrower is the change in the input measurement range. So higher the sensitivity, we will be covering smaller input ranges for the same change in the output. This limits the input range for sensing. There is typically a confusion between sensitivity and resolution. Resolution is the smallest detectable incremental change of input parameter that can be detected in the output signal. So in the resolution, we are not talking about how much is the output change, but we are talking about if we make the input small and small, what is the smallest detectable change in the input parameter that can result in a change in the output. So what is the smallest change of the input parameter is the resolution of a sensor. The next 3 important parameters are dynamic range, repeatability, and physical size. Dynamic range is the operating range of the transducer, and it should be as wide as possible so that it permits a wide range of measurement conditions. Repeatability, which indicates that if I make a certain measurement today using a transducer, and if I make the same measurement after a long period of time, let's say 10 days, with the same input change, the question is whether the transducer or the sensor will give me the same output for the same input change. And if it gives, then it is a reliable transducer. And this indicates the repeatability of the transducer. And the last is physical size. The transducer must have minimal size, weight, volume, so that it can be fitted easily into the measurement system and does not occupy much space. This is a desirable feature. So the basic 5 desired features are linearity, sensitivity, the dynamic range should be large, repeatability should be good, and physical size should be as small as possible. So there are certain advantages of electrical transducers. Because the signal is in the electrical form, this itself gives a lot of advantages. For example, if the signal is in electrical form, then such type of signals can be easily amplified, can be attenuated, they can be added with other signals, they can be mixed with other signals, These can be converted into a digital form, can be stored, they can be transmitted over distance. So there are a lot of advantages because the output signal is in electrical form. Other advantages, the mass inertia effects and the friction effects which might be involved in mechanical systems or systems which give mechanical type of signals, all these are avoided, minimized in electrical transducers. Electrical or electronic systems typically work with low power levels, small power levels, and therefore uh, lesser energy is required to drive such type of circuitry. So these are some of the advantages of electrical transducers. In the next lecture, we will see the classification of electrical transducers based on 4 different criteria. So if you have any doubts regarding sensors, their desired features, as well as the advantages, please write a mail as soon as possible. Thank you.